As you can see from the opening slide here, we're going to talk about simple interest and compound interest today, and about a third of your test, maybe up to a half of a test, will be on this subject, especially the compound interest. Simple interest is not a difficult subject at all. There's a real simple formula that you use to find simple interest, and it's right here. You just simply take the principal times the rate times the time to find the interest. So if I ask you guys to use this formula, the main thing you need to remember is the principal is how much you borrowed or how much you invested. The interest rate has to be as a decimal. So remember, when you're using this formula or the other formulas we're going to use today, don't, like if the interest rate is 7%, don't put in 7, put 0.07. And time is always in years on these problems. So let's take a look at some, and there's another formula down here, but if you understand the one I have highlighted in yellow, using common sense will get you to this one. So this is the main one up here to understand. So let's use that formula in an application here. Let's say Lauren borrowed $1,500 from Cecilia and said she'd pay her back 3 years at 5% simple interest. How much should Lauren pay back in 3 years? Well, just remember I equals PRT. So the interest is principal times rate times time. We want to find the interest. Well, it's the principal, which is $1,500. That's how much was borrowed. Interest rate is not 5, it's 0.05. You need to change the percent to a decimal. And then time is in years, and this was in years, so that's okay just to put a 3 there. If that would have said 36 months, you would have not put 36 there. You would have put a 3 for 3 years. And then you let your calculator do the work after that. You just take 1,500 times your 0.05 times your 3 to get 225. Now notice that doesn't answer the question. That's what the interest is. It says how much should she pay back in 3 years. Well, it's the $1,500 she borrowed plus the 225 is what she should pay back, which I believe is $1,725. And that's what I was speaking of when I talked to you about this formula here. The amount is simply going to just be right down here. The amount's going to be the principal, which in that last problem was $1,500, plus the principal times rate times time, which is interest. So the amount plus the interest, or the amount invested or borrowed plus the interest, is going to be the amount paid back, or the amount you'd have in an investment. This one you have to think a little bit more on this application, but not too bad. If you borrowed $400 from your friend, and your friend said, pay me back $472 after 3 years, what interest rate is your friend charging you? That should say your friend, not her friend. Well, if you have to pay back $472 but you only borrowed $400, I bet you guys all agree that $72 is the interest, right? So we simply use this formula, I equals PRT, and interest was $72. The principal, in other words the amount borrowed, is $400. The rate is what we're looking for. The question is, what interest rate is the friend charging you? And then the time was 3 years once again. I bet you guys agree that 400 times R times 3 is the same as 400 times 3 times R. So we can simply take that 400 times 3 to get 1200, and we still have R. Then use a little bit of algebra to solve for the R. We need to divide by 1200 on both sides, because this means 1200 times R. So the way to get rid of a multiplication is to divide. So we get R equals 72 divided by 1200. And when you take 72 and divide it by 1200, you get 0.06. So that means the interest rate was 0.06, which as a percent is 6%. I believe you might have a couple problems like that on your My Math Lab assignments. Okay, compound interest is used by lending institutions and banks, and because of the time limitations on YouTube videos, I was going to give you a little explanation on compound interest, but basically what you should know is, let's say you invested money and you're getting interest compounded monthly. So let's say you invested $1,000. After 1 month they're going to apply the interest rate to that $1,000. So maybe you have $1,010 in there now after 1 month, and then they're going to apply the interest rate to that $1,010 after the first month to find out how much you have after 2 months. And each month your money grows a little bit, and over time it really makes a big difference with compound interest, which is unfortunate if you're a borrower, but excellent if you're investing money. So money grows over time. It starts growing very rapidly, exponentially. In fact, you can see we have a formula here with an exponent in it, and that's money does grow exponentially with compound interest. So this formula right here is a formula we're going to be using now for the next few minutes, and for any problem that deals with compound interest. The one thing you need to know is this n right here, this n and this n stands for the time periods that the compounded is being done n times per year. So if it says monthly, n would be 12. If it said quarterly, that means your money's being compounded 4 times a year because it's quarterly, 4 times a year. If it says daily, or let's say weekly even, you'd use 52 for n. So the n stands for how many times is your money being compounded per year. The r and the t are the same as the other formula. It's your interest rate and your time. Most students learn better by examples, so let's take a look at the example. If Aaron deposited $5,000 in an account that has an annual interest rate of 6%, compounded quarterly, so notice this is compounded quarterly, so because of that, n is going to equal 4. And interest rate was 6%, so r is going to be 0.06. What's the value of the account in 5 years? So because of that, we know t equals 5. And we just plug it into this formula. So to find out the amount of the investment, we'd take 5,000, which is the principal, times 1 plus 0.06 over 4, because this was compounded quarterly, 4 times a year, to the power of n times t. So we're going to have a 20 up here. I'll put 4 times 5 up here. If I was going to put it in my calculator, I'd just put a 20 to go a little bit quicker. And for 1 or 2 of these, I'll actually show you these computations on the calculator so you get used to using your calculator. And I don't know if you have a graphing calculator or a scientific calculator, but if you remember right, Aaron put $5,000 in, and the formula is 1 plus, and whenever I enter a fraction, I like to put parentheses around it just to be sure that it uses its order of operations correctly. I don't think you'd need to on this particular calculator, but on yours you might want to do it to be safe. So there's my r over n, my interest rate over the number times its compound in a year. And then remember, we have to raise that to a power. So on my calculator, I go right over here to this exponent button, raised to the power of, it's called a caret symbol. Raised to the power of 20, or I could put 4 times 5 there, but I'm just going to put in 20. So I let my calculator do the work. Whoops, somehow I hit another button accidentally, so I got to hit delete here and hit enter, and you can see that that $5,000 grew to $6,734, and if I round, it'd be 28 cents because of the 5 after the 7 there. 42 years. Now, Bill is in a different situation. He didn't invest any money when he was young, but he did get lucky at a casino and won $200,000 and invests all that into the stock market at the age of 50. So we have 200,000 times 1 plus 0.12 over 12, because it's still 12% interest compounded monthly. But up here, he put in at age 50, and we want to know how much he has at age 60, so that's 10 years. So up here I'm going to go 10 times 12. Okay, I'm going to do that on my calculator at home here, just because I can operate it quicker, and I get 200,000 times 1 plus 0.12 divided by 12, all to the power of 120. Because 12 times 10 is 120. I'm getting $660,000 and 77, or $660,077. So even though he invested way more money, he invested $200,000, because he only had it in there for 10 years, his investment is not worth nearly as much, $660,077. Okay, so there's two more examples of compound interest. Interest can also be compounded continuously, which it's hard to imagine this, but it's not every month or every quarter or every week or every day or even every minute. It's continuously being compounded. Then you use what we call the PERT formula, P-E to the RT power. E is on your calculator. You might have to search for it. It's an irrational number that's about 2.718. Don't let that scare you at all. You just let your calculator do the work. So, if $1,000 invested in an annual interest rate of 8% compounded continuously, so there's the key word, it's not quarterly or monthly, it's continuously, what amount will be in the account after 2 years? Well, you use A equals P-E to the RT. The amount's going to be the principal, which was 1,000, times E, interest rate's 0.08, and the time is 2. So there we go. Now, I want to show you on a graphing calculator where you find that. So you go 1,000, and if I go over here to second ln, so I'm going to hit the second button and come down to the natural log button, which is ln. Right above there you can see that e to the x. So it's 1,000 times e to the, if I remember right, it was 0.08 times, I think I said 2 years. And then you, like I said, let your calculator do the work. And that $1,000 after 2 years grew to $1,173.51. $1,173.51. So, you basically had three formulas to learn today. Simple interest, compounded interest, and then compounded interest when it's compounded continuously. The only other formula that you might find on your homework is simply taken from this one, the one we've been using right here. If I ask you to get that P by itself, well, that P is being multiplied by all of this, so you divide by all of that and come up with this formula right here to get when you have to isolate the P. And what this does, if you need to know how much should you invest, like what should your principal be if you wanted to have a certain amount of money at a specific time. So this is called the present value formula, and all it is was it took this formula and it got the P by itself by dividing by all of this on both sides. And an example of that is shown right here. And I need to stay under 15 minutes for the YouTube video, so I'll go over this real quick. You can see that this person wants to know how much should he deposit today that in an account that earns 6% interest, compounded monthly, so that it'll accumulate to $20,000 in 5 years. So you simply want to know the amount's going to be $20,000, and you still use that formula we just talked about a little bit ago, exactly the same as before. So you take $20,000 and divide by that, and it gives you $14,827.44. So that means you need to invest a little over $14,000, almost $15,000, in order to have $20,000 in 5 years at 6% compounded monthly. That's it. Good luck on this section or these sections. Goodbye.